We're going to look at solving our trigonometric equations where we have multiple angles, and there's a technique that we can do here that works out fairly nicely. Let's say that we have the cosine of 3 theta equals -1. Now what we want to do is find all the angles between 0 and 360 that will make this true. Well, we don't want to substitute in for identities, and we did something similar to this in an earlier problem. We're just going to treat this as an angle, and we want to ask ourselves the cosine of what angle is -1. Well, that would be 180. So 3 theta can equal 180. But what we want to do is first of all list these for all of our angles, plus 360k. We're going to narrow it down in just a minute. So 3 theta would be 180 degrees plus 360k. So theta, we'll divide everything by 3, would be 60 plus 120k, where k is 0, 1, 2, 3. So we've got us an expression now that will give us all of our answers. If we wanted all of our angles, this would be our answer. But now we want just those between 0 and 360. So what we do is we start filling in values for k. So if k is 0, then it's going to be 60 plus 0 is 60. If k is 1, then it would be 60 plus 1 times 120, or 180 degrees. If k is 2, it's going to be 60 plus 2 times 120, or 240, and that would be 300 degrees. Now if it's a 3 theta, then we're going to have 3 of these. And if you weren't in doubt, if we went ahead and did k equals 3, well, 3 times 120 is 360, plus 60 is going to be beyond 360 degrees. So this gets us all of our answers. So this is the technique we'll use in our multiple angles. We'll solve for the multiple angle first, then we'll solve for the angle. So if we have the sine of 2 theta equals negative square root of 3 over 2. Then first of all, we'll solve for 2 theta. So 2 theta, the angle whose sine is square root of 3 over 2, is 60 degrees. Now since it's negative, then we're wanting it in the third and the fourth quadrant. So that would be 180 plus 60 would be 240 plus 360k, or 2 theta would be 360 minus 60, 300 plus 360k. So theta is 120 plus 180k, and theta would be 150 plus 180k. Now that would give you all of your answers. If you only want those between 0 and 360, since it's a 2 theta, we'll do 2 of them. We'll start with k equals 0, so that would be 120, and k equals 1 would be 120 plus 180 would be 300. Over here, k equals 0, then it would be 150, and k equals 1 would be 150 plus 180 would be 330. And again, you can know if you've gone too far, because if you put in 2, then that's going to be 360, and you're going to be past your 360. Okay, if we were asked to find the cosecant of 3x minus 1 equals 0. Well, first of all, we'll solve for the cosecant. So the cosecant of 3x equals 1. And we can know that, or we can do the reciprocal. The reciprocal of cosecant is sine. The reciprocal of 1 is 1. And the angle that has a sine of 1 is 90 degrees. Or if let's do this one in radians. So let's say we want to find our x's between 0 and 2 pi. So that would be pi over 2. So 3x would be pi over 2 plus 2 pi k. Now we're going to divide by 3, which is the same as multiplying by 1/3. And that's going to be a little bit easier. So x would be 1/3 times this, which would be pi over 6, plus 1/3 of this, 2 pi over 3 k. That would give you all of your answers. But if we only want them between 0 and 2 pi, then we need to figure them out. So if k is 0, since it's a 3x, we'll do 3 of them. So x would be pi over 6. If k is 1, then we're going to have 1/6 plus 2 pi over 6. Well, that's 1/6. And then getting a common denominator of 6. 2 times 3, 2 times 2 would be 4 pi over 6, so that would be 5 pi over 6. And then for k equals 2, we've got pi over 6 plus 2 times that would be 4 pi over 6, 4 pi over 3, excuse me. And so we have pi over 6 plus 2 times that would be 8 pi over 6, or 9 pi over 6, which reduces to 3 pi over 2. And if you notice that each time you're just adding another 2/3 pi. So we had a 4/6 here. We could have added another 4/6, and that would have given us the 9/6. So this is the idea behind solving for multiple angles. And you can have some pretty big ones. Let's say we had the sine of 10 theta equaled square root of 3 over 2. Well, we'll do this one in degrees. So that would mean 10 theta. Okay, we're going to be talking about 60 degrees if it's in the first quadrant, or if it's in the second quadrant, that would be 120. Since it's positive, we're either in the first or the second. So that would be 120 degrees plus 360k. So theta would equal 6 plus 36k. And theta would equal 12 plus 36k. That would give us all of our solutions. If we wanted our specific solutions, the ones between 0 and 360, well, then we would have 10 of them. We'd start out with k equals 0, k equals 1, 2, 3, 4, all the way up to k equals 9. Or we could just start out, let's just show you a quick thing here. If you have to do a whole bunch of these, okay, k equals 0, then it would be 6. K equals 1, well, it's 6 plus 36 is 42. If k equals 2, then all you have to do is add another 36 to here, and it would be 78, because it's going to be 2 times 36, 72 plus 6, but it's just another 36. And so you could keep going, just adding 36 each time until you had all 10 of your solutions. But it's not something that's really hard to do. And you can even do these on the calculator like we've looked at before. You could check them. Well, let's just take this one. That would be fun. And we're in degrees. Okay. So y equals we have the sine of 10x And then on the other side, we had the square root of 3 divided by 2. Now we want to go from 0 to 360 because that's all, let's say that's all that we're interested in. And let's just see if our window's big enough. It's plenty big for that one. Okay, so if we wanted to make this bigger, we went up to 3, so we could just go up to 2. And then it wouldn't be, we would have a better viewing window. So if you notice, we crossed it here twice, so 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's going to get all of your solutions because we're going to have 10 for this one and 10 for the other one. And if we wanted to see what they were, we can do second, calculate the point of intersection. And let's go back to the beginning since we found a few of those. Whoops. Those are going to be fairly close, so you're going to have to be careful. So enter, 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 and it gives you the 6. And if we went to the next one, it would probably be the 12. Just went over it just a little bit, so enter, enter, enter. That would be your 12. Second, calculate number 5. Enter, enter, enter. And that's your 42, and you could keep going. And if you wanted to see it a little bit bigger, then we don't really need those negative ones, so we could just go down here from 0 to 2, and that might make our graph just a little bit easier to read. So you can play around with your window until you can get a good viewing window for the ones that you're needing. But you can use your calculator to check your answers. Now, we can end up with some problems that look a little different, but they're really not that much different to do. Let's say we had that the sine of 2x cosine of x plus cosine of 2x sine of x equaled negative 1/2. Now this looks fairly involved, but we have formulas that have dealt with multiple angles, and if you look at this, it's the sine of the first, cosine of the second, plus cosine of the first, sine of the second. Well, that was our identity for the sine of a plus b. So this is the same as the sine of 2x plus x, or the sine of 3x equals negative 1/2. So now we want to know what angle has a sine of negative 1/2, and it's negative, so we're in the third or fourth. That would be 30 degrees. So we have 210. 3x equals 210 plus 360k, or 3x equals 330 plus 360k. So x equals 70 plus 120k, or x equals 110 plus 120k. And if we wanted all of our solutions, that gives us all. If we want all of our solutions between 0 and 360, then we would go through with k being 0, k being 1, k being 2. K is 0 would be 70. K is 1 would be 190. K is 2 would be 310. K is 1 is 110. K is, or K is 0. K is 1 would be 230. And K is 2 would be 350. And you could even check that in your calculator. Put sine 2x cosine x plus cosine 2x sine x on one side. Let it graph that. Put in y sub 2, put negative 1/2 and see your points of intersection. You might have to, in some of these problems, use factoring or the quadratic formula. Say we had the sine, or 2 sine squared of 3 theta plus 3 sine 3 theta plus 1 equals 0. And on this one, let's do our answers in radians. We haven't done radians in a little while. So if we look at this, we've got the same angles, 3 theta. We have the same function, sine. So we can either use the quadratic formula or we could factor. I'm going to factor it. 2 times 1 is 2. I want numbers that multiply to be 2 and add to be 3. So that's 1 and 2. So 2 sine 3 theta, 1 sine 3 theta. That gives me the 3. The signs are the same. They're both pluses. If you're not comfortable with factoring, then use your quadratic formula. And you would be finding the sine of 3 theta. So now we can factor out a 2 sine 3 theta times sine 3 theta plus 1. Here are common factors, 1. So we have the sine of 3 theta plus 1 times 2 sine 3 theta plus 1 equals 0. So we said each factor equal to 0, so the sine of 3 theta plus 1 equals 0, and 2 sine 3 theta plus 1 equals 0. So the sine of 3 theta equals negative 1, which means the sine of 270, or 3 pi over 2. So 3 theta is 3 pi over 2 plus 2 pi times k. The angle whose sine is negative 1 is 270, or 3 pi over 2. Now here, instead of dividing by 3, let's multiply by 1/3. So times 1/3, we get pi over 2 plus 2 pi over 3k. Here we would subtract 1, divide by 2, and we want the angle whose sine is negative 1/2. Well, our reference angle's 30, and we're in the third and fourth quadrant. Now, I said 30, but we want this in radians. So in radians, 30 is pi over 6. So that would be 6/6 plus 1/6 would be 7/6 plus 2 pi k. 2 would be 12/6 minus 1/6 would be 11. Plus 2 pi k. Okay, this would give us all of the solutions. If we had to do specific ones, since it's a 3 theta, we would have 3 of them. We would have k equals 0, And I'm going ahead and doing that on most of these just so that you would know what to do. It depends upon the directions. If the directions said find all the solutions in radians, then this is all that you would do. If the directions say find all values of theta where theta is between 0 and 2 pi, then you've got to do the rest of this. So just read your directions carefully and you'll know which one. It's really easier when they just say find all the solutions because we just stop. But if they say, if our directions here had said to find all the thetas, you know, you'd had this little part where theta was between 0 and 2 pi, then you've got to go ahead and do the rest of this. So if k equals 0, then theta's pi over 2. If k's 1, then theta's going to be pi over 2 plus 2 pi over 3. So a common denominator would be 6. So this would be 3 pi over 6 plus 4 pi over 6, which would be 7 pi over 6. If k equals 2, then theta is going to be pi over 2 plus 4 pi over 3. So it's going to be 3 pi over 6 plus 8 pi over 6, or we just did that again, which would be 11 pi over 6. It's not a negative, 11 pi over 6. And then we would do the same thing over here. We've got to, first of all, multiply both sides by 3, or by 1/3. So times 1/3, we would have 7 pi over 18. We're going through and multiplying both sides by 1/3. That's a little bit easier than dividing by 3. So we would have 7/18 plus 2 pi over 3k. And then you would have to go through and list them. You'd have 7/18, 7 pi over 18, and then you would add, what, 12/18 to that, and then add 24/18 to that. This one we would have times 1/3. So we would have 11 pi over 18 plus 2 pi over 3k. And again, if you needed to give all of your solutions, then you would go through and do that. So you'd have 11 pi over 18, and then 11/18 plus 12/18, so 23 pi over 18, and then you would get the next one. So we can get our multiple angles and solve for those.